Hi guys, welcome back. So today, in the earlier video, we had talked about how to multiply the rational expressions. Today, we're gonna focus our energy on how to divide rational expressions. So we're gonna do a fun problem for back in the day, and then we'll do two real fun problems, and then we're out. So let's do this. So problem from back in the day. So when you were in preschool, you were given a problem set that was like 2/3 divided by 1/5. Okay, so what I want to point out is this: if you're comfortable with doing this problem, then you're gonna be comfortable with doing the problems that we're gonna knock out. What if you forgot how to do this? Well, that's why I'm here. Okay, so when it comes to dividing fractions, our primary goal is to write the division problem as a related multiplication problem. So to do that, we're gonna keep the first fraction and then multiply by the reciprocal of the second fraction. The reciprocal of a fifth, you just flip it over. Okay, will give us 5/1 or just 5. Do whatever you gotta do. Okay, and then the toughest part to divide fractions is just to remember how to write it as a related multiplication problem, and then you just take it from there. When we multiply across, the product of 2 and 5 is 10, product of 3 and 1 is 3. Last time I checked, 10 and 3 have no factors in common other than 1. But now the question you ask is this: oh man, I always struggled how to write the how to go from division to multiplication. I know we flip something and I know we multiply, but I forget. So I'm going to share with you a secret that I picked up in Vegas the other day. Well, it was like 10 years ago, but it's a true story. Okay, so pretty much I went to a workshop. Yeah, I'm digressing. I went to a math conference, and then the speaker shared something that a student shared with them, and the student had said copy dot flip. And then at first glance, I'm like, what does copy dot flip have to do with fractions and division? And it's a lot, okay? Because when we say copy, we copy the first fraction. And then we say we keep the first fraction or copy it, and then we say multiply it by. So there's your dot, and then flip. We say we take the reciprocal, and no one in their right mind says, oh, I know how to take the reciprocal. I'm going to invert the numerator and denominator. No, we don't speak like that. We're just like flip it over. Okay? So reciprocal, I got to say it like that. So that's where copy dot flip came from, to remind me how to go from division to multiplication. So we're going to copy the first fraction, dot, multiply, flip, reciprocal of the second fraction. Sorry, I pointed in the wrong direction. Copy dot flip. Take the first fraction, multiply by reciprocal of the second fraction. And if you don't like it, sorry, I'll give you back your 20 seconds. Cool. When it comes to dividing rational expressions, we're going to go ahead and divide them the same way we do our rational numbers or fractions, okay? So if I have a rational expression of the form P over Q, and I'm going to divide it by another rational expression, say R over S, at this point I can't be quick, let's go ahead, cancel or multiply. No, we have to write this as a related multiplication problem. So how are we going to do that? Copy dot flip. Okay, you don't like that? Then just keep the first rational expression and multiply by the reciprocal of the second rational expression. Now that we have multiplication problem, then we can multiply like always. So multiply the numerators and then multiply the denominators. So again, if you can do this from back in the day, you can do what we're going to do right now. With one caveat, I think I said that word correctly. Okay, we need to make sure we factor everything. So let's go ahead and look at our first fun problem. So we have, where am I? We have x squared plus 2x over 5 plus x, and we're gonna divide that by 4 minus x squared, and that's all over 3x minus 2. Okay, so the first thing we need to do, we need to factor everything. Okay, so let me go ahead label these polynomials, and I'm going to show you why. I'm going to say this is number 1, number 2, number 3, number 4, and then we're going to have all the space in the world. Sorry, I'm having technical difficulties behind the scenes. Then we're going to have all the space in the world to show our work, if any. Okay, so polynomial number 1, I want to know what does this factor to. Okay, prerequisite step is to watch out for common factors. X squared and 2x have a common factor of x, so when we factor it out, that will leave you with x plus 2. One polynomial down, 3 more to go. Number 2, there's nothing to factor, okay? The thing is, it would be nice if it's in descending order, so we're going to put x plus 5. Now, do you have to fix it so the polynomials are in descending order? You know what? You don't, okay? I like to, because if things are supposed to cancel, I want them to look exactly the same, not kind of the same, okay? Polynomial number 3, where am I? 4 minus x squared is for the same reason. Let's go ahead and put that in descending order. So x squared is negative, so we're going to put minus x squared. 4 is positive. Now, we got a binomial. There's no minus in the middle, okay? So I can't go straight to difference of squares. But check it out. The leading coefficient is not positive. Let's make it positive. How? By factoring out a negative 1. I'm just going to put negative sign. Negative x squared over negative 1 will give us x squared. 4 over negative 1 will give us negative 4. Cool. So now, binomial minus, we're going to aim for difference of squares. And in this case, we do have a difference of squares. How can we tell? We can tell because x squared is the square of x and 4 is the square of 2. Okay? So remember, from back in the day, if we have difference of squares of the form a squared minus b squared, then this will factor to a plus b times a minus b. So this should factor to x plus 2 times x minus 2, or its conjugate. So 3 polynomials down, 1 more to go. Number 4, there's nothing. It's perfect, okay? It's in descending order. There's no GCF other than 1. The degree is 1, so we're good. So this is what I'm going to do. Okay, I need a break. I'm going to rewrite the problem without actually writing the polynomials. We're going to write the place markers, okay? The numbering. We have 1 fraction bar, 2 division sign, 3 fraction bar, 4. Okay, yeah, you cannot see that. Sorry, I forget that just because I can see my paper, that doesn't mean that you can. My mistake. Okay, what are we going to do now? We're going to write this division problem as a related multiplication problem. So copy dot flip. We're going to copy the first fraction dot multiply flip by the reciprocal of the second fraction. Okay, now at this point we're going to substitute back all the polynomials. So we have number 1, which factor to x times x plus 2, over number 2, which factor to, oh, actually no, it was fine. We didn't, it was already factored. It was just not in descending order. Multiplied by number 4. For number 4, well, oh, it was perfect. Okay, yeah, I'm gonna cut that short. Fraction bar number 3, which factor to x plus 2 times x minus 2. And again, you don't have to organize your work like this. I'm just giving you a way to show all the work, if any, and then still have it organized without a chaotic mess. Okay, so let's go ahead, cancel it out. You can just can't start slashing right now, but I told you my speech from before, I just focus on the denominators and take it one factor at a time. I need to have like a way to organize myself instead of seeing, can I cancel more? X plus 5, can I cancel it with something? No. How about x plus 2? Yeah, we sure can. So quotient will leave us with 1. X minus 2, no, there's nothing to cancel with, so that's it. Okay, so that will leave us with, we have a x and a 3x minus 2. Okay, remember, multiply across. Then we have a x plus 5 times the x minus 2. We're gonna have to wrap up that x plus 5 because it's gonna have a neighbor. Okay, oh, I'm sorry, I will make sure I look at my screen. Sorry about that. So now, I know we nailed it. We looked at this one factor at a time, but you know, sometimes my fingers slip, so it doesn't hurt to see if we overlook something. I got an x plus 5, nope. X minus 2, no. Okay, there's nothing to cancel it with it. There's nothing to cancel with it, so we're good. Okay, guys, so I owe you 2. I said we're gonna do 2 problems. That was our first problem. I'm gonna go ahead and hunt our second problem. Okay, guys, so our second and final problem has been found, so let's do this. So we have 2 rational expressions separated by a division sign, so let's go ahead and divide. You organize your work however you like. I'm going to go ahead and use the same strategy. To give myself plenty of space to show my work, I'm going to go ahead and number these polynomials, okay, one at a time. So 1, 2, 3, 4. Why am I doing that? Well, that's because I'm not going to go from polynomial straight to answer. So I want to have some space. So number 1, we have 64x cubed plus 1, okay? Prerequisite step is to watch out for common factors, but we don't have any. Binomial plus, we're gonna go straight to sum of cubes. So that one was a doozy. So let me remind myself. If we have a sum of cubes, if this is our question, then this is our answer. For the binomial factor, it's a plus b, and for the trinomial factor, it's a squared, ab, b squared. So let me go ahead and put the reminder of SOAP. Same, opposite, always positive. Oh, where did SOAP come from? Oh, I'm crying. That means you didn't see the earlier video. Okay, so it's really hard for me to see this, so I'm gonna do the mold. So do I really have a sum of cubes? 64, I do not recognize it as a perfect cube. I do recognize it as a perfect square because it's the square of 8. And I don't have the perfect cubes memorized because I don't work with them that often. So I just go in order. 1 cube, 2 cube, 3 cube, 4 cube. Okay, so it's 4 cubed. 4 to the third power gives us 64. So that means that 64 is a perfect cube because it's the cube of x. X cube, oh sorry, 64 is a perfect cube because it's the cube of 4. I should have counted my fingers. Okay, x cube is a perfect cube because it's the cube of x. So altogether 64x cubed is a perfect cube because it's the cube of 4x. 1, is that a perfect cube? Yeah, and it's also a perfect square, but for our purpose we want to aim for cubes. 1 is a perfect cube because it's the cube of 1. Okay, so if this is our question, this is our answer. So let me identify the bases. Okay, our first base is 4x, so that's like our A. Our second base is 1, that's our B. So if this is our question, this is our answer. So this should factor to A plus B, or 4x plus 1 multiplied by the trinomial factor A squared. So we're going to take that A and square it. 4x times 4x will give you 16x squared minus AB. Product of A and B, namely 4x and 1, will give you 4x. Sorry, that doesn't look like a minus sign. It looks like an underscore. My mistake. Always positive. B squared, and the square of 1 is 1. Okay, so that's it. What can we do with it? Nothing. Okay, if we were able to factor more, then this wouldn't be the formula. Okay, so that's one polynomial down, 3 more to go. Polynomial number 2, I need to enunciate my words. Okay, so we have 4x squared minus 100. Prerequisite step is to watch out for common factors. I think 4 goes into 100. Who has a calculator? Yeah? Okay, cool. Alright, so let's do this. Let's go ahead and factor out the common factor of 4. When we do, that will leave us with x squared minus 25. So we have factored, but I'm like, can we factor more? And the answer is yes, okay, because binomial minus, we do have difference of squares. If you see it, cool, and if you're like, no, I want to do the mold, then go for it. X squared is a perfect square because it's the square of x. 25 is a perfect square because it's the square of 5. So x squared minus 25, remember the formula, we have a squared minus b squared. If we have difference of squares, then this will be our answer. A plus b times a minus b. So this should factor to x plus 5 times x minus 5. But let's not forget that we yanked out the common factor of 4. Cool. We have 2 polynomials down, 2 more to go. Polynomial number 3, we have 64x squared minus 16x plus 4. Cool. 64x squared minus 16x plus 4. So I'm not quite sure what the common factor is. I know that 16 and 4 have a common factor of 4. So let me see if 4 goes into 64. And it does. Okay, so the GCF is 4. Let's go ahead, factor out of 4. When we do, that will leave us with 16x squared minus 4x plus 1. Cool. So we have factored, but because the degree is more than 1, we need to ask ourselves, can we factor more? Alright, trinomial. Leading coefficient is not 1, so if it's factorable, we're going to go ahead and use the AC method. Let's do the corresponding x game. We want factors of AC that add up to B. So product of A and C, namely 16 and 1, will give us 16. Value of B is negative 4. So then I'm like, what are factors of 16 that add up to negative 4? None. Okay, there's no solution. Okay, x game has no solution. If the x game has no solution, then that means that the trinomial is not factorable. Okay, so we can't break it down. So I guess when we just take out the GCF, the trinomial is factored completely. Alright, 3 polynomials down, 1 more to go. Polynomial number 4, okay, go ahead, look at your notes, is 4x plus 20. Prerequisite step, watch out for common factors. Let's factor out of 4, and that will leave us with x plus 5. Cool, fantastic. The degree is just 1, so we can't break it down. So I'm a little exhausted, so let's go ahead and do a visual break, and then we're going to rewrite our problem, not the actual expressions, but just the numbering. And unfortunately, I can't show you everything, so we're just going to write this over. 1 over 2 divided by 3 over 4. Okay, catch that. Okay, we have 1 over 2 divided by 3 over 4. So this is how we are going to quickly copy over the problem. Okay, let me see if I can have a better pen. No, where am I? Okay, so let's go ahead. Before we copy over the polynomials, let's go ahead and write this division problem as a related multiplication problem. Copy dot flip. Okay, we're gonna copy. I'm so glad I went to Vegas that year. Dot flip. Okay, copy dot flip. Take the first fraction and then multiply by the reciprocal of the second fraction. Okay, so number 1, where am I? Okay, let me zoom out. Okay, number 1. You're just gonna have to trust me because I can't put it in the same screen. Number 1 factor to 4x plus 1 times this trinomial factor. Okay, again, you're gonna have to trust me, and if you don't, I'm crying. Okay, so polynomial number 1 factor to 4x plus 1. Let's just go ahead, zoom in anyways. Times 16x squared minus 4x plus 1 over number 2. Number 2, you're going to have to trust me. But I think I could show you. Oh, it's right there. This is number 2. This is 4 times x plus 5 times x minus 5 times. I got a little bit excited with the fraction bar. Sorry. Okay. Times what? Number 4, which is 4 times x plus 5 over, fraction bar, I put it prematurely. Number 3, which is 4 times 16x squared minus 4x plus 1. Fantastic. Yeah, remind me to look at the screen. Cool. So we have factored all the polynomials, or all the numerators and denominators. We wrote the division problem as a related multiplication problem. Let's go ahead and knock this out so we can be out. I have a 4. Can I cancel it with something? I sure can. Someone said, what if I cancel these 4s instead? That's fine. That just means you're cool like that, and you just go straight to attack mode and cancel whatever catches your eye. I don't like to do that because sometimes I don't see things, so I need to do things in order. Okay, I got an x plus 5. Can I cancel it with something? I sure can. I got an x minus 5. Can I cancel it with something? Nope. I got a 4. Can I cancel it with something? Nope, because it's already used up. I got this trinomial. Can I cancel it with something? We sure can. And because we looked at these factors one at a time in an order versus just at random, I'm almost positive we didn't overlook anything. But it doesn't hurt to take a second look at the answer that we're about to write. The numerator has a 4x plus 1. Is it being multiplied by anything other than 1? No. The denominator, we have an x minus 5 and a times 4. Okay, so altogether we have 4 times x minus 5. And again, let's take a second look. I got a 4. There's no integer factor to cancel it with. I got an x minus 5. There's no x minus 5 to cancel it with. One of the questions that I get is this. Can I distribute the 4? You know what? You sure can. Do I recommend you do? No. Why not? Because when you leave it in factored form, it highlights that it's reduced. But if you want to distribute the 4, go for it. But please make sure that you don't make a technical difficulty. The worst thing you can do to yourself is have the right answer, but because you're an overachiever or the overachiever in you, when you distribute the 4, if you make a mistake, then I guess your answer is wrong. Okay, so just leave it in factored form. Okay guys, so I said we were going to do our 2 problems. That was our second problem, so we're out. Until next time.